Hey, welcome back. This is Mrs. Marquette, and we're going to do some factoring polynomials in quadratic form. Before that, I want to take a look at everything that we've done so far. So the types of factoring that we have right now are leading coefficient of 1. This is add multiply. Okay, so that's when I've got just x squared minus 5x plus 4 or something like it. I need numbers that add up to 5 and multiply to 4. When the leading coefficient is not 1, this is the AC method. Sometimes we'll have a perfect square trinomial, meaning we've got a perfect square in the front and a perfect square in the rear. And I can double check to make sure that x plus 5 times x plus 5 is x squared plus 10x plus 25. Difference of squares is when I have two terms, each perfect squares with a minus in the middle. And I've got two terms that are exactly the same, except one is positive and one is negative. And then GCF, this one should actually probably be way up at the top because this is what you always check for first. A number 1. So on 6x squared plus 15x, they both have a 3x, and what's left over is a 2x plus 5. So those are all the types that we've seen so far. This last type is factoring polynomials in quadratic form. So this might look a little funky, x to the 4th minus 16. Because we haven't seen a power of 4 yet except with greatest common factor, but there is no greatest common factor. But I want you to notice that x to the 4th minus 16 looks really close to a difference of squares problem. And in fact it is. So if I set up two parentheses, I want to think what times itself would give me x to the 4th. Well, x squared and x squared does. And then what times itself would give me 16? It is a 4 and a 4. If I put a plus and a minus, that is the difference of squares. Even though it was a 4th power, I can take care of that with just changing my first two terms. If I want to double check, make sure this is good, x squared times x squared is x to the 4th. X squared times negative 4 is negative 4x squared. Positive 4 times x squared is positive 4x squared. And positive 4 times negative 4 is negative 16. My middle terms still cancel out, even though there's an x squared. So I get x to the 4th minus 16 as my final answer. That's kind of going to be the story of all of these in quadratic form. This means it's not quite what we've seen before, but it looks a lot like it. Usually this is when we have an x to the 4th power going on. So let's look at number 2, x to the 4th plus 10x squared plus 16. And I want to think it's not quite what I've seen before, but I may have seen something a lot like it. So if I go back over to my box, I think that one looks most like our add multiply problems, specifically because our leading coefficient is just a 1. So I'm going to set up two parentheses. The first term has to multiply to x to the 4th. So I'm going to put an x squared and an x squared. And then I need two numbers that multiply to add to 10 and multiply to 16. So factors of 16 are 1 and 16, 2 and 8, 4 and 4, but I think 2 and 8 are going to be our correct choices. So I'll do plus 2 and plus 8. Now you might be thinking, hey, what's going to happen with this middle term? It's got an x squared. So let's just double check and see what falls out. X squared times x squared is x to the 4th. X squared times 8 is 8x squared. Hey, that's where that x squared comes in. 2 times x squared is 2x squared. And 2 times 8 is 16. Combine some like terms, I get x to the 4th plus 10x squared plus 16, check. That one works out. So we'll notice that when we have a quadratic form, we'll always have the first term being some power, and the second term has to be half of that because I need those middle terms to have that same power. Number 3 also looks like an add multiply problem because if I set up two parentheses, I can put an x squared and an x squared, and then I need two numbers that add to 4 and multiply to negative 21. Those are going to be the numbers 7 and negative 3. So I put positive 7 and a minus 3. And I can double check with multiplying. x squared is x to the fourth, minus 3x squared, plus 7x squared, minus 21. Again, that checks out if I combine some like terms. So hopefully this stuff is going to start feeling more comfortable. You just really got to check and make sure that you have your first power right. We'll do a couple more of these and then let you try the last one. Number 4, I notice here that I can always check for a GCF. So my GCF in this case is a 3 and an x. So I'll take a 3x out. And then what's left is an x to the third minus 8. Ooh, you might notice that this is a difference of 2 cubes just from the last video. So I can write x, 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 and 8 is a 2, 2, 2. Circle some pairs. When I set up my 2 parentheses, I'll have an x and a 2, and then x squared, 2x, and 4. Same opposite, always positive in this case is going to be negative, positive, positive. So I'm going to call that a SOAP factor for my second step. So that we should also probably put in our box too. That's another option when we're just doing any old factoring problem. Well, this one also has a lot going on, so I'm going to check for GCF. In this case, GCF is a 4x squared. Put a 4x squared on the outside, and I get x to the fourth minus 5x squared plus 6. And I can factor this as well, so this is an add-multiply problem. My add-multiply problem in this case is going to be an x squared and an x squared, and I need 2 numbers that multiply to positive 6 but add to negative 5. I think that one is going to be negative 2 and negative 3. I can also check if either of these is a difference of 2 squares. There is a difference for both of these factors, but the minus in the middle isn't quite enough. 2 is not a perfect square, and neither is 3. You guys go ahead and try 6. Okay, number 6 was an add-multiply problem, so I get x squared plus 2 and an x squared plus 7. Last but not least, we've got just one more set of zero product property. We have done this before, so hopefully this is going to feel good for you. Number 7, I've got a product equaling 0, so I can set each part equal to 0. 3x plus 2 equals 0, and x plus 3 equals 0. Hopefully these are starting to get fast for you. So this equation is x equals negative 3. In this one, you may or may not need to show all your steps. 3x equals negative 2, divide, and x equals negative 2/3. I don't care what order you list those answers. On number 8, you should be noticing that I have 4 things to set equal to 0. I have a 2 equals 0, an x equals 0, x plus 4 equals 0, x minus 4 equals 0. This can happen. You could have a whole long string of all of those factors. It's fine. But 2 equals 0 doesn't make sense. Please cross that out so I know that you know it doesn't equal 0. X equals 0 is already an answer. X equals negative 4, and x equals positive 4. So when I list, I'll say x equals 0, and plus or minus 4. Okay, number 9 is going to get a little tricky. I've got x squared plus 4 and x squared minus 4, so I can set each of these equal to 0. And I'll notice that this second one is a difference of squares, so I can factor that one further. I'll get x plus 2 and x minus 2. And in this case, I'll get an x plus 2 equals 0 or an x minus 2 equals 0. So those two x values will be x equals plus or minus 2. For this second equation, x squared plus 4 equals 0. Well, let's do something here. If I subtract 4 on both sides, just to see what happens, I get x squared is equal to negative 4. And we know that a number squared is always going to be positive, so this actually doesn't make sense. We're going to say this is a non-real answer. We will learn in second semester that there are some times when we'll get a number to make this equation work. It's the number I, but we're not going to deal with that in this chapter. So we'll only do the ones that have real answers. Number 10, we've got a GCF of 2 and y. So I'll take out a 2, y. I'm left with a y to the 4th minus 9 is equal to 0. Okay, how can I factor y to the 4th minus 9? Well, that's a difference of squares. So I get y squared minus 3, y squared plus 3 is equal to 0. So 2y might equal 0, y squared minus 3 equals 0, and y squared plus 3 equals 0. 2y equals 0 means that y equals 0. Y squared minus 3 equals 0. That is almost a difference of squares, but we can't quite factor this. So this has a real answer, but we're going to learn how to do this next chapter. Okay. Y squared plus 3 equals 0. When it's a plus, those do not have real answers, because of what we just saw in the last problem. Okay, last few here. My GCF here is x squared, so I'll put an x squared on the outside, and I'm left with x minus 3 is equal to 0. This actually set me up really nicely. I have x squared is equal to 0, or x minus 3 is equal to 0. Okay, x squared equals 0. The only way that that would happen is if x was equal to 0 itself. And the second one will only work if x is equal to 3. So my two answers are 0 and 3. Check a GCF again. This time I've got a 2x squared. So 2x squared, x squared minus 9 is equal to 0. Can set up all these problems. 2 equals 0, x squared equals 0, and x squared minus 9 equals 0. 2 equals 0 doesn't make sense. X squared equals 0 is only true if x is equal to 0. And then x squared minus 9 equals 0. Here I can factor this again. That's a difference of squares. X plus 3, x minus 3. So x either has to be 3 or negative 3. So final answer, 0 plus or minus 3. Okay, so that is the last bit of factoring. Go ahead and do some practice problems. Make sure that you feel really comfortable with this, and come and see me if you've got questions. See you guys later.